Hello, everybody. My name is Austin Ralph, and today we're going to be discussing the topic of database and database types. So, to start off, just go through an overview. We're going to go through what exactly is a database, two different types of database systems, and then talk about database engines, servers, languages, the various types of databases, popular ones that are out right now, as well as future databases that are in development and the advantages and disadvantages of them. So to start off, what exactly is a database? Well, a database, simplistically, is a collection of information organized in such a way that the computer program can quickly select desired pieces of data. And it's organized by fields, which are the individual entries into the database, records, which are the entire entry itself, and then files, which are then stored in the system and then can be easily accessed by a user. So these three components essentially make up what a database is. And then a database management system stemming from a database is just the collection of programs that enables you to store, modify, and extract the information from a database, and it can range in size and complexity. So usually small systems are with personal computers, small scale businesses, and then the large systems are the large mainframes, like corporate mainframes and what have you. And then you can find these in the form of computerized library systems, automated teller machines, some flight reservation systems, and other inventory systems. And then also there are relational database management systems. So these type of DBMS, the acronym for short, it essentially stores data in the form of tables. So it requires few assumptions about how the data is relatable because it's obviously related if it's in a table. And it also allows for it to be, it shouldn't say few, it's viewed in different ways. There's different perception about the data that can occur. And then a single database can be spread across several tables, so there's also a lot of variety in the format and presentation of these databases. And then database engines and database servers are also a key component of databases. So an engine is part of the management system that stores and retrieves the data and includes an IPA that enables you to control the engine without going to the user interface, which is also very important for the ease of use and for users that aren't as tech savvy as some. Then servers are the back-end system of the database and includes tasks that do data analytics, storage, data manipulation, archiving, and other non-user specific tasks. And then languages are another key component. There's three types. There's data definition, which defines data types and the relationships between them. And then there's manipulation language, which performs daily tasks such as insertion, updating, deletion of the data. And then there's query language, allows for searching for information, computing derived information. Then the types of databases. The ones that I found to be most prevalent, most occurring were operational, end user, centralized, distributed, personal, and commercial. So firstly, operational are databases that store data relating to the operations of the enterprise. So it can be organized along function lines such as like marketing, production, employees, payroll, what so be, but it just stores it as terms of a topic within the enterprise or like a functional topic, as you might put it. But the second one, end users. So databases like these share by users and contain information meant for use by end users, which in this case means managers at the different levels of a company. It's not concerned more with individual transactions and it's more focused on summary information. And it's much faster process than operational. The third is centralized. So these databases store the entire information and application programs at a central computing facility. The data validation and certification carried out by these are all done at a central location. the local area office keeps a record of all the recordings and everything that occurs, and there's hardly any processing, so it's a very easy process. Then there's distributed. So these databases have many contributors from the common databases as well as the data compared from local operations. This reduces the communication by ensuring that detailed local information remains stored at the local facility, and is more of a client-server technology. The personal databases are containing information that's meant for use only among a limited number of users. It's generally within the same department. It's maintained on personal computers. It's also subject specific and user designed, as well as it uses simple and less powerful management packages. So it's more personal and more geared towards personal computer use. And then finally, there's commercial databases. These databases access is provided to users as a commercial venture. So pretty much it contains information that external users require, but would not be able to afford maintaining at such large database levels. Its access is sold as a paid service, and it may offer statistics regarding commodity, foreign exchange, and stocks, companies and performances, importers and buying patterns, and decided case laws. So it's more geared towards the enterprise sector, if you might put it. And then some popular databases out there right now. There's a bunch, but a common one that keeps on occurring is Google is a huge database. I mean, it's probably the biggest database in the world. And then there's Wikipedia, Encyclopedia Astronica, Sightseer is another big one. Bibliotech is another big one. There's countless out there, but these are just some of the ones that I found to be most frequent. And then there's cloud databases, which are the future of databases. These databases are going to be vital as cloud computing is evolving and developing. So, like I found some of the advantages to be that it increase is accessibility. It is automatic failover. So there's a failover, like if something fails, there's automatic like reassurance that it was saved or there's a backup for it. There's automated on-the-go scaling. There's minimal investment and maintenance for this hardware, and it's overall just better performance. But there's some fallouts. There's security and privacy issues. Obviously, nothing is really safe when dealing with cloud computing. Information can be accessed by virtually anyone. So the security issues around that are obvious. And then there's potential loss or inability to access this data given a disaster, server malfunction whatsoever. So that's really the only fallouts, but it's going to become very useful in the coming years once it starts developing. And then overall, just some of the advantages that databases can provide. These databases are vital for they reduce data redundancy. So it can summarize the data. It can give you increased consistency, greater data integrity. It's more reliable. It's more secure. You have better access to all the information. There's less cost involved with it, and it facilitated development of new application programs. So it's led to the development of future technology in this area. But there are some fallouts. It's very complex. There's a lot of moving parts, and there's very time consuming to design. There's a lot of parts that go into it. There's a bunch of costs for hardware and startup. There's also damages to databases, affects all the programs. So that can really, if there's one system within the database that it malfunctions, it can affect the entire program. There's a bunch of training required to understand it, which can be time consuming and costly. And there's a bunch of conversion costs from moving from file-based traditional systems to new advanced database systems. So there's a bunch of extra costs involved with databases. So in conclusion, databases are very vital for analytics and research entities. It can open new windows for data interpretation and collection. it provides more quality archives, so you can reference things. You can look back into the past and spot trends and patterns. It's very adaptable. It's very flexible, as well as there's a high variety. And it's only going to continue with the advancement of cloud computing. And there's advantages definitely outweigh the negatives when it comes to it. The security issues will always be prevalent, but they will be more manageable as the technology evolves. So that was all I had for today. So my name once again is Austin Ralph, and I want to thank you for listening. Yeah, so I'll see you next time.